What is IT infrastructure? IT infrastructure, also called technology infrastructure, is what enables a company to build and run the applications that underpin its business. IT includes compute network, workplace, data platform, and edge capabilities. Traditional infrastructure primarily considers hardware, data centers, and services that are manually configured, managed, and maintained. With modern cloud infrastructures, applications and data are accessible from anywhere. Thus, IT includes a mix of cloud environments, on-premise data centers, and edge computing devices, all connected by enterprise networks. This flexibility requires a dynamic infrastructure engineering disciplines that integrates innovation, automation, and optimization. What are the components of IT infrastructure? Components of IT infrastructure. IT infrastructure has seven main components. Computer hardware platforms. IT include client machines that are desktop PCs, mobile devices such as laptops. Operating system platforms. IT includes platforms for client computers occupied by Windows operating system. Balance by server level run by Windows is 75% and another 25% is run by Unix or Linux. The other components are enterprise software applications, data management and storage, networking and telecommunications platforms, internet platforms, and consulting and system integration servers. There are several major components that modern IT infrastructure needs to run seamlessly, including on-prem data center, give companies greater control over security, governance, system performance requirements, and more.
Many companies also own and control their own data centers because of the lack of application compatibility with cloud-based operations, as well for security for their own data. A hybrid/multi-cloud provides on-demand resources over the internet to users wherever and whenever they are. It also benefits from innovations and advancements from service providers like Microsoft Azure, AWS, or Google. Hybrid clouds mix between private and public good because hybrid clouds allow data and apps to move between the two environments. A multi-cloud environment has more than one cloud of the same type from different service providers, and that's for some beneficial users. And now we'll talk about how do we build a system that will last up to 3 years without breaking or becoming obsolete. This question keeps many developers awake at night, and lately there is a new trend of adopting open source software for their projects, but can free software replace enterprise level software in industries line? Furthermore, electronics manufacturing depends on the company size and needs. In our current digital era, it has become impossible to isolate from the world at large because we are connected with sophisticated software and hardware. Infrastructures contain software and hardware that is used for tracking valuable goods and creating more efficient solutions for everyday tasks, which makes it so important. And now let's talk about the types of hard infrastructures and projects that are related to them. Number 1, aviations, like airports and air traffic control. Number 2, telecommunications, like telephone wires and cables, and also satellites. Number 3, recreation facilities, like public parks and playgrounds, and also historical sites. On the other hand, the soft infrastructures include institutions that are essential to the economy and quality of life, such as the financial system, the education system, the healthcare system, the system of government, law enforcement, and emergency service.
Infrastructure, hardware, and software. The delivery of genuinely personalized medicine on a European scale requires unprecedented levels of computation on massive amounts of heterogeneous biomedical data. IT Future of Medicine proposes solutions to facilitate the emergence of new ICT to benefit medicine and focuses on providing key underlying hardware and software infrastructure to cater both for the immediate demands of other IT Future of Medicine platforms and the increasing clinical deployment of IT Future of Medicine. IT Future of Medicine is expected to utilize 3 kinds of compute resources for different types of computation. Large integrated simulations will require powerful parallel supercomputers, for which IT Future of Medicine consortium members may have access to PACE research infrastructure. Early discussion has begun with PACE in order to present this new need for the usage of massive computing power. For some other types of computation, IT Future of Medicine will also be able to utilize capacity computing resources such as cloud or grid. These will be accessible via a single portal managing fast exchange of data, with systems based on existing European infrastructure already in production such as EGI.EU. Finally, specialized computing devices dedicated to fast data processing will be located close to the scientific equipment acquiring data to perform primary data processing. The demands of IT Future of Medicine go beyond the capabilities expected from roadmaps for general purpose HPC technology over the next decade. IT Future of Medicine addresses this by combining existing large-scale computing infrastructure with customization and optimization of key components of the technology chain to enable a giant leap forward in overall computational capacity for biomedical data processing, modeling, and simulation. Through extensive industry involvement, IT Future of Medicine will ensure knowledge transfer to industry and advances in computing technology in Europe.
Underlying compute and storage capabilities that can match IT future of medicine's demands. High-performance computer systems built around heterogeneous storage and compute technology will be developed. Customization and optimization of hardware and software for the IT future of medicine use cases will deliver order of magnitude improvements in capability. In particular, bioinformed computing has potential to make otherwise impossible computational challenges practical by mimicking the way the human body self-computes in real time. Support for development of IT future of medicine, workflows to run anywhere. Virtualization layers will support both HPC high-performance computing clusters and cloud or grid environments. That will be a key to development of IT future of medicine on a larger scale, allowing the workflow to be executed on a mix of dedicated compute appliances, local HPC clusters, private cloud, grid, remote HPC centers, e.g. PRACE, or public cloud environments. Protection of patient data and compliance with ethical and regulatory requirements. A security service will be provide authentication, authorization, and data access protection across IT future of medicine datasets. Efficient and scalable data acquisition and model parameterization. Dedicated computer systems for primary data analysis will be designed to be located close to data acquisition devices, and novel algorithms will address the inverse problem of using acquired data to parameterize reference models for a specific individual patient. Ease of use, intuitive user interfaces, and visualization technologies will make personalized medicine practical in a clinical environment. A series of component prototypes, the deployment of major components for use in other platforms, and deployment of 2 integrated prototypes deployed at 30 months in hospitals for clinical use will be demonstrated. This aims to bring demonstrations of practical applied solutions to our stakeholders to successfully answer to the challenge of the practical application of personalized medicine in daily clinical use. Define future use models and innovative solutions for industrial applications, value chains of the drugs development, diagnostics, medical device sensors.
What happens when infrastructure doesn't take the needs of everyone into account? What happens when the infrastructure that is vital for daily life is accessible and affordable for some but not others? People can be restricted from infrastructure intended to make their life easier. At the end, infrastructure is the foundation for development. It's key to providing human dignity and improving well-being. This means that having an infrastructure that can build a world that leaves no one behind.